Hello everyone, welcome to the video. Now we'll start with something really essential in our day-to-day lives, which is fuels. Fuels are a very important part of our life. From powering our homes to driving our cars, fuels are everywhere. But what exactly are they and how do they work? Let's see in the detail. Let's start with basic understanding what is fuel. Well, fuel is essentially combustible substance. Its main constituent is carbon. When burned properly, it releases a significant amount of heat. This heat is incredibly useful and can be both economically harnessed for both domestic and industrial purpose. The real magic happens in the combustion reaction which is given here. This is where the fuel it's a simple yet powerful equation. Fuel plus oxygen from the air combined with high temperature yields products of combustion and most importantly a lot of heat. This heat is what we capture and we use. Let's see the classification of fuels. Fuels aren't just one thing as they come in many forms. We can classify them based on their occurrence and state as given here. As we can see, fuels are divided into two types or two classes, namely primary or secondary. Primary fuels are those which are directly found in the nature. We can think about it in solid form such as wood, coal, or cow dung. And liquid fuels such as crude oil, vegetable oils, gaseous, we have natural gas. And the second type is secondary or derived fuels. These are such fuels which are derived or processed, manufactured from primary fuels or other raw materials. This includes solid types such as charcoal, liquid such as alcohol, and gases in water, gas. Now, how do we measure the energy content of fuel? That's where calorific values comes in. It's defined as the total amount of heat obtained when unit mass or volume of fuel undergoes a complete combustion at standard temperature and pressure, which is STP. Here are the two key types, namely gross calorific value, also known as high calorific value, is a heat obtained when products of combustion are cooled down to room temperature. And the net calorific value (NCV) or the low calorific value represents the practical heat obtained excluding the latent heat of water vapor that's lost during combustion. Here's a simple formula to state them. The net calorific value equals to the gross calorific value minus the latent heat of water form. This distinction is important for real world applications. Now there are some few characteristics of good fuel. So, what makes a good fuel? There are several characteristics, and now we are going to see it. The first one is high calorific value, meaning it releases a lot of heat per unit. It should release a lot of heat per unit. Ignition temperature. The temperature should be moderate, not too high or not too low, allowing for easy and safe ignition. The next is combustion control. The fuel should create such energy which should be manageable, and critically it should also produce non-toxic products, and it shouldn't release any harmful type of gases which are very harmful to the nature or toxic even to the humans. A good fuel also should have minimum or non-combustible matter. We want to burn fuel, not waste. It should be cheap and easily available, making it accessible for wide use. It needs to be easy and safe to transport whenever it is needed. Hence, the transportation of every fuel should be safe, then it can be said as a good fuel. Continuing to our list, the next is storage space. A fuel should require really less storage, and also it should burn efficiently with the available air, making its use practical. For automotive uses, it needs to be suitable for IC engine. Ideally, a good fuel also should not contain moisture, as moisture reduces its efficiency. And finally, the last point, it should not contain any harmful volatile matter which can impact the performance and safety. So thank you for your attention, and now let's wrap up our fuels. We hope this has given you a clear understanding of what fuels are and how they are classified and what makes a good fuel. So let's stop it here. Thank you.